This video will be about the binomial theorem. First, we'll begin by discussing Pascal's triangle. Pascal's triangle has a 1 in the first row, 2 1s in the second row, and then each number is the sum of the numbers above it. So if we look here, we have a 1 and a 3. We add them together, we end up with a 4. Then we have 3 plus 3, so we get a 6 under that. 3 and a 1 again, 4, and then on all of the edges we have 1s. If we look at Pascal's triangle, we can see that there is a relationship between that and combination. So for example, in our fifth row here, we can say that 1 is equal to 5, choose 0, 5 is equal to 5, choose 1, 10 is 5, choose 2, and 5, choose 3, 5, choose 4, 5, choose 5. Another common way to write this is as a parentheses. So these are the same thing. And in general, the nth row and the mth element of Pascal's triangle is equal to n choose m minus 1. So the binomial theorem deals with when you have a binomial, which is a polynomial with two terms, and you're multiplying it by itself many times or raising it to an integer power of n. Let's just investigate what happens for small numbers of n. So a plus b to the power of 1 obviously is just a plus b. A plus b to the power of 2 is equal to a squared plus 2ab plus b squared. A plus b to the power of 3 is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Let's do one last one. This is equal to a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. Now let's see if we can find a pattern here. In all of these, we see that as you go through, the power of a is decreasing. So here we have a to the power of 2, a to the power of 1, a to the power of 0, and similarly a to the fourth, a to the third, a squared, a, and a to the 0th, while the power of b is increasing. So here we have, for example, b to the 0, b squared, b cubed, and b to the fourth. And then what about our coefficients? Our coefficients are 1, 1, 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1. If these numbers look familiar to you, that's because they are the rows of Pascal's triangle. So another way we can say this is that a plus b to the power of n is equal to the sum k equals 0 to n of n choose k, that tells you the coefficient, a to the power of n minus k times b to the k. And this gives you all of the terms of the expansion of a plus b to the power of n.